Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
This is a typical crater on the moon. It's here because, once upon a time, an asteroid crashed right into it. Yep, a lunar crater forms when an asteroid, meteoroid, or a comet slams into the moon's surface. And as you can see, it's happened a lot. But one crater formed in a very different way. But then, how did it form? Well, let's rewind a bit. There's a widely accepted hypothesis that the moon itself is a product of collision, just like all these craters. But that collision was way tougher. It happened over 4.5 billion years ago when a huge Mars-sized planet called Theia crashed into Earth. That event threw a bunch of debris into orbit. Eventually, it came together to form the moon. Now, for a while after that, the moon was basically a giant ball of lava. But because the early moon was very close to Earth, our planet's gravity kept squeezing it, making it even hotter. In the end, though, the moon drifted farther away, cooled down, and formed a rocky crust. Now, moving on, about 4.3 billion years ago, an asteroid the size of a small country, like Nepal, way bigger than the one that wiped out the dinosaurs, slammed into the moon's far side. It left an enormous crater called the South Pole Aitken Basin. It's up to 5 miles deep and about 1,500 miles wide. For comparison, that's roughly the distance from New York to Dallas and deep enough to swallow Mount Everest. Now, scientists think that impact may have dug up and scattered some ancient stuff from deep inside the moon. A mixture of materials nicknamed creep, short for potassium, rare earth elements, and phosphorus. It's like a chemical time capsule from when the moon was still a lava ocean. Now, you want to know the reason why this area could be even more scientifically interesting than we realized? You see, until recently, researchers believed the asteroid came from the south, slamming upward and spreading a bunch of radioactive material, that very creep, around the crater's northern rim. But after looking closer, scientists realized the impact actually came from the north, which means all that valuable creep ended up on the southern edge instead. And guess what? NASA's Artemis 3 mission happens to be targeting that exact southern region. Researchers started questioning the old southern impact theory when they compared the moon's crater with others across the solar system, mainly Mars's Hellas Basin and Pluto's Sputnik Basin. Here they are. See? All three have this bizarre teardrop or avocado shape, wide on one side and pointy on the other. And exactly that pointy end usually shows which direction the asteroid came from. In the case of the South Pole Aitken Basin, that means the asteroid hit from the north, not from the south. To confirm it, scientists dug into old data from NASA's Lunar Prospector mission. It orbited the moon in 1998 to 1999. That spacecraft measured radioactive elements on the surface and found high concentrations of thorium, a key part of creep, around the basin's southwestern rim. Now, the Artemis 3 mission is NASA's big plan to put humans back on the moon for the first time since 1972. If everything goes according to schedule, the launch is set for mid-2027, right after Artemis 2 wraps up. See, Artemis 2, which is supposed to launch before April 2026, will be sort of a dress rehearsal. Astronauts will orbit the moon without landing just to make sure that all the systems work smoothly, a cosmic test drive. Artemis 3 is where things are going to get real. The astronauts are expected to land near the moon's south pole, in one of 9 possible locations NASA has scouted out. The only problem is timing. Artemis 3 has already been delayed a few times, and so has Artemis 2. Artemis 1 launched in 2022. It was an uncrewed test flight that went around the moon and came back just fine. So, next up is Artemis 2, which will take real astronauts further into space. Then comes Artemis 3, the big one. Astronauts are supposed to hang out on the lunar surface for about a week doing sciencey stuff before heading home. After that, Artemis 4 and 5 will build and expand a new mini space station orbiting the moon. It's called Gateway. Think of it as a pit stop in space. Astronauts can dock there, live for short missions, do experiments, and prepare for landings. NASA's building it with help from the European Space Agency, Japan, and a few others. The astronauts are going to travel in the Orion spacecraft, launched by NASA's Space Launch System, a massive rocket taller than the Statue of Liberty, and strong enough to fling people to the moon. To actually land, they'll use the Human Landing System. SpaceX's Starship is supposed to take the first cruise down to the moon's surface once it proves it can land safely. In the long run, NASA's not going to stop at the moon. The big goal is Moon to Mars. Hopefully, we can use everything we learned from Artemis to build a lunar base and eventually send humans all the way to Mars. And who knows? Maybe when people land on the moon, they'll be able to figure out another unsolved mystery: flickers, glows, or beams of light that sometimes illuminate our satellite. Let's dig deeper into this mystery, shall we? On the night of April 19, 1787, astronomer William Herschel spotted something weird: a bright light glowing on the dark part of the new moon. It shone for hours and was almost as bright as the Orion Nebula. What he saw probably was what scientists now call a transient lunar phenomenon, or TLP. Basically, quick little flashes or color changes on the moon's surface. TLPs can look like glowing patches, reddish or purple spots, or even hazy clouds that suddenly appear and fade away. Over the last 2,000 years, people have recorded around 3,000 of these strange moon flashes, using telescopes, cameras, or sometimes just their own sharp eyes. So, what's really going on up there? Well, there's no single answer. Lots of different things can cause TLPs, from meteor impacts to gas releases or even electrical activity. The length of the flash, which can last anywhere from a split second to several hours, gives scientists clues about what's behind each mysterious lunar light show. The super short flashes, lasting less than a minute, are most likely caused by tiny space rocks crashing into the moon. Even a meteoroid, the weight of a billiard ball, can hit the lunar surface hard enough to make it glow for a split second. The heat from the impact makes rocks shine and then quickly fade as they cool down. For a long time, scientists suspected these quick flashes were caused by meteor hits, but they couldn't prove it until the 1990s, when high-speed cameras finally became common in lunar research. Even then, it wasn't easy to confirm. Short flashes could have just been camera glitches or electric noise. The only way to be sure was to catch the same flash from 2 or more places at once. Well, that happened for the first time during the Leonid meteor shower in 1999, when scientists recorded real impact flashes on the moon. Later, we got more proof that the moon was often peppered with space rocks. While the flashes seemed to cluster in certain areas, like Oceanus Procellarum, one of the moon's big dark plains, that's likely just because of where scientists have focused their cameras. A 2024 study showed that meteoroids actually hit the moon evenly everywhere. Now, flashes that last a few minutes are probably caused by something totally different: gas leaks from inside the moon itself. Studies from 2008 and 2009 found that when gas like radon builds up under the lunar surface, it can suddenly burst out. Hey, I know how that feels. And when this radioactive gas escapes and decays, it gives off a faint glow we can see from Earth. Interestingly, those glowing spots often line up with areas where scientists have already found higher radon levels. Then, there are the long-haul lights. They stick around for hours, like the bright glow William Herschel saw back in 1787. A 2012 study suggested those could actually be caused by solar wind, a stream of charged particles coming from the sun. When that solar wind hits lunar dust, it can charge up the particles and toss them into the air, well, into space, creating massive dust clouds up to 60 miles high. These floating clouds might bend or reflect light from stars or planets nearby, making it look like the moon itself is glowing. So hopefully, we'll get the answers once the Artemis mission lands and starts its exploration. Hey, I can hardly wait.
The moon might be hiding trillions of dollars worth of materials beneath that dusty surface, and NASA is about to get a piece of it soon. Their new lunar drilling tech just passed its first big test, and it could open up an entirely new frontier: space mining. This isn't just a scientific milestone, This could change the US economy forever and maybe even reshape life on Earth. That's because they found something rare in lunar soil, something that could become essential for us in the future: helium-3. Okay, so you know helium, right? It's the gas that makes birthday balloons float. Helium-3 is not that. It's a special isotope of helium, which basically means it has the same number of protons, 2 by the way, but a different number of neutrons. That's chemistry speak for it's rare, like super rare. Here comes the sad part. Earth had helium-3 once, a lot of it actually. But during our planet's formation, a lot of it escaped into space. Turns out, it's super light, so it didn't stick around. But we can still find it here and there, mostly inside our planet. I mean, there's some of it literally trapped underground. Or even a lot, as some recent studies might suggest. But still, the problem is that extracting helium-3 is expensive, limited, and seriously difficult. So difficult, in fact, that getting it from the moon suddenly sounds like a piece of cake. To really understand why extracting helium-3 in space might be easier, we need to quickly compare Earth and the moon. So here's the sun, right? This huge ball of fire in the sky constantly shoots out tons of helium-3. When this helium-3 reaches Earth, our planet's magnetic field acts like a giant invisible shield, basically saying, "Nope, not here," and it deflects most of it away. But the moon doesn't have a friendly protective magnetic field like Earth does. So when helium-3 reaches the moon, it hits the surface directly and gets trapped in the lunar regolith. I'm talking about that loose layer of dust, soil, and rocky debris covering the moon. And there might be tons of it, literally. Some estimates put it somewhere between 1 and 3 million tons of helium-3. The best part is that almost all of it is probably sitting right in the top layer of lunar soil. So instead of heavy-duty drilling, it could be as easy as just scooping up some moon dust. That's why a lot of people think getting helium-3 from our natural satellite could actually be way easier, or maybe even cheaper, than digging deep underground here on Earth. Now, you're probably thinking, why go through all that trouble? I mean, if it doesn't work for birthday balloons, what's the big deal with helium-3? Well, for starters, it's already being used in advanced medical tech, like magnetic resonance imaging and X-ray. But here's the real game changer. Helium-3 could actually end our dependence on fossil fuels for good. This rare isotope could be used for advanced nuclear fusion reactors here on Earth. In other words, it could give us nuclear energy that's not just super efficient, but a whole lot safer too. See, most nuclear power plants today run on a process called fission. They use uranium-235, and when those atoms split, you get a ton of energy. But you also get something else: radioactive waste. And yeah, it's just as dangerous as it sounds. But helium-3 is different. It could power future reactors with a process called fusion. If you mix helium-3 with a type of hydrogen called deuterium, you get a lot of energy, but without the dangerous waste. It could be cost-efficient too. Let's say a single space shuttle cargo bay could carry about 25 tons of helium-3. That would be enough to power the entire United States for a year. And scientists believe there's enough helium-3 on the moon to power the whole world for 10,000 years. These are only estimates for now, but the future potential is so exciting that the demand for helium-3 is already skyrocketing, and so is its value. In 2024, some experts say that the helium-3 market was worth about $670 million. This year, it's expected to hit around $730 million. And 10 years from now, experts believe it could reach nearly $1.6 billion. Sorry for all the numbers, I just wanted to show you why mining the moon matters. It might actually save us from a future energy crisis by giving us almost endless, clean nuclear power. Everything sounds great so far, but there's one big challenge. Mining helium-3 on the moon is one thing. Bringing it back to Earth is a whole different story. So let's look at one possible solution. First, robots or specialized machines would drill into the lunar soil or simply scoop up moon dust to collect the helium-3. Then it gets packed into containers and launched off the moon, heading for Earth. When the containers get close to Earth, a ship called the Space Rapid Transit will pick them up in orbit. Think of it as a reusable space truck with engines that can even use air for thrust. Finally, the ship would land at an airport here on Earth. From there, the helium-3 would head straight to power plants, giving us clean, safe, and almost unlimited energy. See how challenging it sounds, right? Of course, specialists are still figuring out the best way to transport helium-3. But one thing is certain, we're getting closer and closer to building a full mining base on the moon. NASA recently tested a new drill technology called Trident. And as soon as it touched the lunar surface, it started working right away and performed perfectly. For now, its main purpose is to bring soil to the surface so scientists can study it. They want to learn more about how strong the lunar regolith is and how it reacts when drilled. That's definitely an exciting step towards extraterrestrial mining. Because it's not just helium-3, you know. There are a lot of other valuable things that can be taken from the moon. For example, there's water ice on the moon, and from that, we could extract oxygen and hydrogen. Then there could be rare and expensive metals like platinum, rhodium, and iridium. We could even mine iron, silicon, and aluminum, which would be perfect for building things directly in orbit, like future space stations or other infrastructure. Now that we know how important mining the moon could be, you're probably wondering, is any of this even allowed? I mean, who actually owns the moon? The short answer? Nobody. Even though NASA is up there doing research, that doesn't mean the United States owns the moon. Back in 1967, some nations signed the Outer Space Treaty. It basically says no one can claim ownership over our natural satellite or any other celestial body. Not an asteroid, not a planet, not even a random rock floating out there. So, if a country wants to explore the moon, sure, they can do it, but they can't plant a flag and say, "This is ours now." Here's where it gets messy. Companies. There isn't much of an agreement about what private businesses can and can't do out there. For example, a private company sets up a moon base. They land a successful spacecraft, build a small station, and even start digging. The base itself belongs to them, sure, but the land they're sitting on does not. Everyone is on the same page up to that point. The tricky part is, the treaty doesn't really spell out what happens to the materials they dig up. Nobody is totally sure if those resources would even belong to them. And if the materials are not technically the company's, can they even sell them? It's hard to say. So yeah, sorry. Even if you had the cash to build your own lunar base, you probably can't just scoop up helium-3 and bring it back as a souvenir. I mean, unless you want to risk becoming the first person ever banned from the moon.
August 23, 2023, a day when India's Chandrayaan-3 spacecraft made history by becoming the first to touch down on the lunar South Pole, a place we can't normally see from Earth. What makes this lunar hideaway so fascinating to scientists? Well, it turns out it's hiding something precious: lunar ice. This place is believed to be more abundant with this ice than what we found up north. And it's not hard to see why scientists are so buzzed up about it. It's a frozen water source, and it could become our key to building a permanent lunar home, or even fueling missions all the way to Mars. Scientists knew about this ice for over 2 decades, since the NASA spacecraft accidentally stumbled upon it during one of the missions. Then in 2018, NASA triumphantly declared that they're 100% sure about it. They said that the south pole of the moon is abundant with water. Now, picture this. Future lunar settlers could tap into this water supply. It could help us sustain life in the barren lunar landscape. Plus, by cleverly splitting the water into oxygen and hydrogen, we could receive both air and rocket fuel. All this will make moon missions more feasible and self-sustaining. It's also a great glimpse into the past. This ice, maybe as old as the moon itself, could unlock the moon's and Earth's deep mysteries. But it turns out that water isn't rare in space at all. There might be lots of planets out there where life could thrive. We know this because we started finding water vapor around stars, and this water is remarkably similar to the water in our own solar system. This discovery suggests that the water on Earth originally came from space. Water forms around stars in the cloud of extremely hot vapor. Then it turns into ice and sticks to tiny dust particles. These particles stick together over time and become bigger objects, like comets, planets, and other things. Some of these become comets and planets in our own solar system. And this is how water is being spread across the universe, and it may be how it got to our planet and the Moon too. Scientists think that the lunar ice might have journeyed here eons ago. Maybe it hitched a ride on water-rich asteroids that smacked into the Moon's surface. All this has big implications for us. The southern pole is an ideal canvas for humanity to establish a real moon base. Imagine brick domes connected by secret underground tunnels. They'll be bustling with people busily operating computers. Some others will be cruising the lunar landscape in their jeeps or on their way to mine precious resources. We have some pretty cool ideas on how to build this. First, you probably imagine hauling hefty and water-draining shelters all the way from Earth. But maybe there's a more effective way. Think about our history as a civilization. Every time we ventured to a new place, we surveyed the surroundings for available resources and used them to survive and thrive. This is how we spread across our own planet. So why shouldn't we spread across the Moon the same way? Now, you might wonder what resources the Moon might offer. We know about the ice, and it can be turned into water. But we can clearly see that our planet lacks lush greenery and edible food. Well, it might not be obvious, but the Moon does have something to offer: mineral resources and sunlight. Unlike Earth, where the sun rises and sets, the lunar poles offer quite a beautiful sight. The sun gracefully orbits the horizon the entire day, which means it can provide an almost uninterrupted source of power. Imagine living in a world bathed in perpetual sunlight. I'm sure the solar panels will love it. Me? Not so much. Still, we could use not only the sun's light, but also its heat. Honestly, we should just use everything. If we're left with spare metal while producing oxygen, find a purpose for that metal too. We need to treat the environment responsibly, not only on Earth, but on the Moon as well. Which is why scientists are learning how to turn the Moon's most abundant resources, regolith, into sturdy bricks. They've been quite inventive in figuring out how to create moon bricks. Scientists want to use the sun's heat to melt lunar dust, layer by layer, essentially creating a 3D printer for moon dust. Engineers have also cooked up bricks using solar ovens and zapped lunar soil with microwaves. They become quite adept at it. So yeah, perhaps we're going to establish a little brick factory on the Moon and build regolith houses. It's like Minecraft in real life. As soon as you find some cool new material, you gotta build a tiny house with it. If successful, these bricks could be used to construct entire buildings, potentially covering inflatable modules or giving new life to abandoned landers. So, will astronauts need to become skilled bricklayers? Well, they won't do everything themselves. We'd have to create a small automated system involving robots working collaboratively. Humans will, of course, oversee the construction site. Despite all this automation, scientists believe that living on the Moon is going to be, well, call it cozy. The designs may involve stacked living quarters or multi-purpose areas. However, there would be some challenges too. On the Moon, things get extreme. Imagine scorching temperatures that can go up to 212 degrees Fahrenheit during the day, and at night, they plunge down to a chilly minus 290 degrees. And it's not just the weather. The Moon gets relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these things gradually wear down anything on its surface. Another big challenge is the lunar dust. On the Moon, there's no air to breathe, and the dust there can cause problems. And this one isn't only regular dust. It's super clingy and can even make astronauts sneeze and have watery eyes, as if they're having a lunar hay fever. It can also damage equipment and spacesuits. It's not something you want to mess with. Scientists have found that the dust is made when meteors hit the moon, creating tiny particles and sharp glass shards. It's toxic, and its tiny particles can float around in low lunar gravity, making it hard to breathe. Unlike on Earth, the moon doesn't have wind or rain to clean it away. So now they're studying it to find out how to prevent this annoying problem from ruining their entire mission. There's more to this lunar haven than meets the eye. Scientists also want to delve into the mysteries of low-frequency electromagnetic waves there. These waves are whispers from the far reaches of the universe. These elusive signals have remained hidden from us for ages. We only caught some cacophony of radio and other background noise, but that's it. On the moon's dark side, however, we can finally record and study them. Studying these waves will help scientists to unlock the secrets of the universe's origins. It's not just about the Earth or the moon. We're talking about peering back to the very beginnings of our world. Our new lunar lab might help us to forever reshape our understanding of the cosmos. So, NASA has some big plans on the moon now. Their Artemis mission completed a successful return to Earth in December 2022 after nearly a month in space. It ventured far beyond the moon. This mission proved the capabilities of some of our recent technological developments that will help us explore Mars. The goal of Artemis is to establish a lasting presence on the moon. They want to create a gateway, like a space station in orbit around the satellite, to help with the landings. Artemis 2 is set to carry astronauts to lunar orbit in 2024, and during Artemis 3, which should take place in the mid-2020s, 2 astronauts will touch down near the moon's south pole. It's quite possible that the lunar base will be built within the next couple of decades. So, stay tuned. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one skywatcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
It's the year 2031, and the first human has just set foot on the red surface of Mars. It was a long flight that lasted 172 days. It was a tough journey. There were a lot of technical issues. There were some physiological obstacles. astronauts had to deliver tons of equipment and energy-generating life support systems to the red planet. Those responsible for the mission had to understand how to deal with low-pressure atmosphere and catastrophic sandstorms, how to keep people safe on Mars' surface, and how to bring them back to Earth after the work is done. It does sound like a science fiction story, but soon it's going to be our reality. But the coolest thing? It's not the limit. After exploring Mars, people might set even more ambitious goals, and this is what some of them may look like. The next planet to visit could be Venus, but it would be a challenging task. Venus is also called the morning or evening star, all because it shines so brightly in Earth's sky that it's the first one to appear after sunset and the last one to vanish after sunrise. But in terms of exploration, Venus is very unfriendly to humans. Its atmosphere pressure is about 92 times as great as the pressure on Earth. And the temperatures on its surface are, on average, 850 degrees Fahrenheit. Modern technologies wouldn't allow us to build an infrastructure that would allow people to survive on the planet for longer than a couple of minutes. But then, why would we set sail for Venus? Here's a curious thing. At the height of 30 to 40 miles above the surface of the planet, there are the most Earth-like conditions in the entire solar system. The pressure there is almost the same as in the mountains on Earth, and the temperatures range from 70 to 85 degrees Fahrenheit. If the planet's atmosphere was made up of oxygen and non-toxic gases, we could live there without any additional equipment. Or we could go to Phobos and Deimos. Those are Mars's moons. It would be the first time humans set foot on the moon of some other planet. Phobos is located a mere 3,700 miles away from the surface of the red planet. It would take no longer than a day to reach it. This potato-shaped piece of rock is quite small, a mere 13 miles across. This is the reason why it has a very weak gravity. Deimos is a bit farther away from Mars, about 15,000 miles, but this mini-moon is even smaller than Phobos. It's a bit more than 7 miles across. In other words, visiting these moons wouldn't be unlike landing on an asteroid, and the greatest challenge astronauts would face would be leaving the surface of Mars. To do it, they would need loads of fuel. So, most likely, the first trips to Phobos and Deimos would be launched from space stations orbiting Mars. We could set an even more ambitious goal and head for Jupiter and its moons. The distance between this gas giant and our home planet is 365 to 600 million miles. This distance can be so different because the planets follow their elliptical orbits around the Sun, getting closer, then further apart. The minimal distance occurs every 13 months. If people set off on this long journey during this period of time, it would still take them about 2 years to get there. Since Jupiter is mostly gas, on-planet exploration wouldn't be possible. We could probably fly around the largest planet in the solar system and even dive into its atmosphere. But much more interesting for exploration objects would be Jupiter's moons. Let's say Europa. This natural satellite has a water ice crust. It can be from 10 to 15 miles thick. Under this crust, there might be liquid water. The core of the moon might consist of liquid metal inside a rocky shell. Its super thin atmosphere contains some oxygen. Considering all this, it would be a rather comfortable place for people to explore, if not for its temperature. It doesn't rise above negative 240 degrees Fahrenheit. We could visit another of Jupiter's moons. That's called Ganymede. It's an ice satellite with a very thin atmosphere that contains oxygen. Or Callisto. It's the second largest among Jupiter's moons. Its icy crust is about 124 miles thick, and it's very cold on the moon, around negative 220 degrees Fahrenheit. People could also send an expedition to Saturn and its moons, for example, Titan or Rhea. The gas giant itself is twice as far away from Earth as Jupiter. It means it would take astronauts more than 3 years to get to this planet. But if the spaceship was launched from a space station on Mars, it could reduce the travel time by 25 to 50%. But even if the starting point of this expedition was Earth, with advanced technologies like nuclear thermal propulsion, such a journey could take a year or even less. Saturn can't be explored directly, so researchers would probably start with its largest moon, Titan. It's also the second largest moon in the solar system. This natural satellite has an atmosphere that mostly consists of nitrogen. The pressure on its surface is twice higher than that on Earth. There are winds and rain on Titan, lakes and rivers, but those consist of liquid ethane and methane rather than water. It's actually a good thing. We'd have a lot of resources to produce fuel and energy. Rhea is the second largest of Saturn's moons. It's made up mostly of water ice. Its atmosphere is super thin, but it also has some oxygen in it. Actually, all the largest moons of Saturn have only one serious drawback. It's freezing cold there. On the bright side, they all have plenty of resources to produce energy and other life-sustaining elements. And it would be much easier and faster than the same process on Mars. But what if we could explore exoplanets? Those are planets that travel outside our solar system. If we manage to get so far away from Earth, maybe we could reach some potentially habitable worlds. It could be Proxima Centauri b. It's the closest to Earth exoplanet, and recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. It means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star, so the radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. It would take way longer to reach potentially habitable Gliese 832c. This exoplanet is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. Gliese 832c is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this parent star is a red dwarf, it's much cooler and dimmer than the Sun, so Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that, unfortunately, Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth.